There are now two viewpoints. One of them is a chance model. It is a model that clearly specifies randomness. It says the people on the jury panels were selected at random from the eligible population. And then there's the alternative viewpoint, which is simply that they weren't. Notice that the alternative viewpoint doesn't say why they weren't or how they weren't, it just says they weren't. So the question is, selected at random or not? To answer this question, we have to consider what we are comparing. We are comparing two distributions. Remember the blue chart and the gold chart. To compare two distributions, we need a new statistic. Why is that? The people on the panel are of multiple ethnicities. We have 5 categories, not 2, and we have to compare all 5 in one distribution and another. The distribution of ethnicities is categorical with multiple categories. So we need a distance between two categorical distributions. We know how to find the difference between two numbers, or the distance between two numbers. If you have numbers a and b, you just subtract. A minus b is the difference, and the distance is the absolute value. But now, we don't just have two numbers. We have the two numbers in the Asian ethnicity category, we have the two numbers in the black ethnicity category, and so on and so forth. We have lots of pairs of numbers. And we need one combined measure of the distance between all of those pairs. Let's see how to come up with such a distance, and that will serve as our statistic that we are going to use to decide between the two viewpoints of how the panels were selected. It's a good idea to look at the jury table once again. It's quite natural to look at differences line by line. What were the differences in each of the categories? So we'll create a new table called jury with diffs. That is jury with a column of differences. And it's this column minus this column. You could do it the other way if you want. And since we're going to do an array operation, we are going to extract the column as an array. So we have the differences. In one case it's 0, but then in the other cases there is some difference. Take a moment to look at the difference column. What do you notice? Look at the minus differences and compare with the plus differences. See anything? That's right. The total of the minus differences and the total of the plus differences is exactly the same, apart from sign. So for the plus differences, you have 0.14. For the minus differences, you have minus 0.14. They're exactly the same. That is a reflection of the fact that these two bar charts both represent distributions. So it's the same 100% represented in two distributions. And so the amount by which the blue bars exceed the gold must be exactly the same as the amount by which the gold bars exceed the blue. Otherwise, the two totals can't both add up to 100%. And so you're saying that the negative differences and the positive differences have the same size, the same absolute value. And it's that quantity that we are going to use as our statistic. Let's see how to compute it without separating the positive and the negative. We're going to do something rather crude, which is we're just going to take the absolute value of every single difference. What happened there? Wrong table name. So we now have a column of the absolute values of the differences. If you add them all up, you'll get the size of the negative differences as well as the size of the positive differences. That's 0.28, and that's double the 0.14 that is the total positive difference. It has to be double because we're counting both the plus differences as well as the minus differences. So the statistic that we are going to use is what we have just computed, but we are going to divide that by 2. And we get 0.14, which is exactly the sum of the plus differences. In terms of the bar charts, that is exactly the amount by which the gold bars exceed the blue, and therefore also the amount by which the blue bars exceed the gold. This distance measures how far off the distribution of the eligible jurors is from the distribution of the panels. It has a name. It is called the total variation distance between the two distributions. It quantifies how far the gold histogram, the gold bar chart, is from the blue. To calculate the total variation distance, we find the differences in the individual categories, take the absolute values, add them all up, and divide by 2. We could have extracted just the positive differences and added those up. We'd have got exactly the same answer. The reason we don't do that is that it's just faster to add the whole lot of absolute values and in the end divide by 2. We know it's going to be the same. Let's take a moment now to summarize what we have learned about our new statistic by writing a function that calculates it. We're going to have to calculate these distances quite a few times, so it helps to have a function. Distribution 1 and distribution 2 are, you can imagine them to be two arrays representing two different distributions on the same categories. And what this function is going to return is exactly what we have calculated here. The sum of the absolute values of the differences in each category. That gives us twice what we want. We'll divide by 2, and that is a measure of how far off the two distributions are. In particular, it measures by how much one of the distributions exceeds the other, and it doesn't matter which you call which. To see whether our function does the right thing, let's apply it to the columns of the panels and the eligible jurors. It doesn't matter which you put as the first argument and which you put as the second. They just better be arrays. So we will take, both of those were in our jury table, so just for brevity of writing, we will take jury.column panels as the first array, and then jury.column eligible as the second. And look, we get 0.14, which is exactly what we got when we did the calculation longhand. This function is going to be very handy. We're going to use this several times. What does it calculate? It calculates total variation distance. What's that? Well, every distance has a way of calculating. If you have two numbers, you know how to calculate the distance between them. This is now a distance between distributions. Total variation distance says, take each category, find the difference between the two proportions. Take the absolute value, that's the distance between the two proportions in each category. And then add up all of those and divide by 2. Right, we'll take a pause now to see where we are. We have seen that there is a difference between the distribution of the eligible jurors and the distribution of the jurors on the panels. We have now worked out how to quantify that difference. And now we are all set to look to see whether that measure that we have developed, the distance, could have happened due to chance. And that's the next thing we're going to do.